told you that you cannot start your variable name with numbers or special characters. Only special character allowed is an underscore. We've created a few variables. I gave you a simple Darcy's law example to tell you where this can come of help, and I gave you the entire idea about you being the coder of a software, of a tool. You should think of your program as if you were developing something for your company, right? And the key behind every good programming practice is how much can you automate it. So that's why variable assignment is a good step towards it. And we saw that as we keep on varying various values, the resultant formula, it keeps on auto updating. If in case you wanted to print a variable, we looked at input statements and how it accepts in default format of a string. We had to typecast it to a number. We looked at the f strings, formatted string to display a string along with the variable's value, not just the variable's appearance. Then we repeated the Darcy example with all these advancements. Then we looked at a few data types. We looked at strings, how to slice a string, discussed a few doubts. We looked at list, how it is important. It's like a bag of various kind of details. Then we looked at one of the important data types. We talked about mutability aspect of strings and like immutability of strings and mutability of thought of as the ability to be modified. Then we talked about a tuple. Some people call it a tuple, whatever you might want to call it. That's all good. We just saw that a tuple is nothing but a list with parentheses and it can never be edited again. Further, we looked at one of the important data types, which is dictionary. And a dictionary was a good practice because we could store things with a mapping, with a title and their respective details. I told you that if you keep on updating a dictionary, add them, the dictionary keeps on varying. Finally, I also gave you a sneak peek into something which we'll be looking at tomorrow. The fact that it can be converted to pandas data frame and played around with, plotted around with, and so on. It looks really pretty when we print it in the data frame format. And yep, there we ended the session. We had a few discussions. All right, all set and ready for session two. Okay. In this session, we will be looking at, finally, you can see that on the title as well. We'll be looking at loops, functions, and if else statements, right? As always, I mean, I'll stop after I complete my content and we will be flexibly going to, revise a few things, discuss whatever doubts we have and all. So don't worry if when I say something you don't get it, don't worry. I will of course give you enough time to go back on it and discuss it with me. So type your queries in the chat and I'll come back to them later on. Right? Okay. So the topic in here is there are three topics we have to look at. Okay. There are three topics we have to look at. Let me type the title here. If else statements, functions, and loops. And my favorite are the later two sections because they give you more power, they give you more abstraction, they allow you to become a mature programmer because all the algorithms that you see in textbooks and whatever you are reading in computational physics, for example, you can code them up as your customized algorithm inside a function, and you can call that function your own creation and then keep on using it wherever you want to go. So let's start with if else statements. Okay, I have an example and we will start with that example. Okay, so the topic one is if else statements. Start with it. Before we even start with it, let me first talk about comparisons in Python. Okay, let's first talk about comparisons in Python. In Python, comparisons can be done using these things. Okay. Greater than symbol, greater than equals to symbol, symbol, less than equals to symbol, double equals to, not equals to. All these are, this is the exhaustive list of comparisons possible in Python. And you can use greater than equals to, and the result of them will be, result will be a truth value. Okay. In Python, true and false are two keywords. You can see as soon as I type a word true, it comes out in green color, which is Python's way of telling you that, hey, mate, this is a keyword that I already have reserved in my memory. So don't you dare use it like a variable name. All right. Similarly, a false, if you type it, again, it comes out as green color. Okay. So the result of whatever comparisons you set up, if the comparison is true, the result will be true. If the comparison is false, the result will be false. Okay. And always remember, true in Python is equivalent to 1, and 0 in Python is equivalent, false in Python is equivalent to 0. Okay. All right. Let's see some examples. For example, is 5 greater than 3? The answer to this comparison should be true. There you go. Is 3 less than 5? The answer is true. Is 3 greater than 5? The answer is false. Is 3 double equals to 3.0? Again, there's a difference between a single equals to symbol and dual equals to symbols. A single equals to is an assignment. A dual equals to is a equality check. Okay. Okay. Let me ask you this. Let me see the answers in the chat. What would you expect this to print? What would you expect this to print? And think about it. What should be the result of this? I'm looking at the chat if in case anyone wants to answer. 3 is being checked for equality against 3.0. Kapil says it should be true. Okay. Perfect. Yep. I think it should not be equal. I mean, even if I ignore all the Python knowledge I've had, I just focus on, I see mixed answers in the chat. Both are right on their own senses, but I will tell you what Python thinks of it. And just the first session that we learned about, that knowledge is sufficient to answer this. Did we talk about data types in the first session? Of 3, it's an integer. But if I check the type of 3.0, what will be the type of 3.0? Anyone? Type of 3.0, what should be the output of this? Float. So do you see some reason why Python might be some hint behind why this is giving you, this should not give you true? Wow, this should not give you true, because the type of these two data types are not equal. So there we go, we saw a loophole in equality symbol. Okay, the data types of both of them are different, but when you are checking for equality, they are saying true. But there is a limit in Python up to which this can be true, and after that it becomes false. So you can see this is still true, which is a very, very significant loophole in Python. So be very, very cautious when you are trying to solve some algorithmic problems where the significant digits are they matter a lot. I mean, even this much difference is considered to be a significant difference. Then make sure you remember that Python will interpret as true. It's not false. We are seeing in our naked eyes that this is not equals to, they are not equal, but Python has a limit up to which it assumes it assumes equality. So this is a red flag right away of equality check. It's only an approximate equality check, and it's not a clear equality check. Okay, I've had problems with this in the past, so please remember it is an approximate equality check. Because for oil and gas engineers, I mean, we deal in decimals a lot, so this can cause some problem like it had caused me. So always remember this, right? But normally, otherwise, it will always give you what you are thinking. Okay. Similarly, if you check for 3 greater than equals to 3, what should be the answer to this? The answer to this should be true. 3 greater than 3 should be false. Okay. Is this very clear about the comparison statements? Let's check something else. 3 not equals to 3. 3 not equals to 3. The answer to this should be what? The answer to this should be, is 3 not equals to 3? Is that true or false? 3 is not equals to 3. It's false, right? I'm giving you a practice of this because this will be a key and all these kind of things they come in. Combining multiple comparisons together. Okay? Combining multiple comparisons together. For example, now I want your answer to this. 5 is greater than 3. The way to combine them is and. For example, I want to combine two conditions, and 3 is greater than equals to 4. Okay? Any guesses what should be the output of this? You can see that I'm trying to bring that good old Bodmas kind of mindset here. I'm putting everything inside parentheses, whichever I consider to be one expression. I'm putting that inside a parenthesis so that that execution happens first, and then the and operator is executed. Okay, always remember that. Whenever you are in doubt, use parentheses, just like in plain math we always explicitly apply parentheses. I never understand operator precedence, so never try to get confused. Always use parentheses. So let's I see some answers in the chat. Let's look at what should be the answer. So 5 is greater than 3. The output of this is, let me type comments here. 5 is greater than 3. The output is true. 3 is greater than equals to 4. The output is false. And like we all know about the AND gate, true and false will be false. Brilliant answers. So you can see the false comes in. Let's see whether we can also, like in C++, we can use ampersand symbol in place of AND. Can we use it here as well? Yes, we can. Okay. So we have AND operator. We can also, now if I replace this AND with an OR, can you tell me what will be the answer? I'm replacing AND with an OR. Does that change anything or does that keep it the same? Yes, exactly, Soumya. So it becomes true. Okay. It becomes true because AND only AND requires both the conditions to be true, whereas OR just wants one condition to be true. Let me give you an example, a bit of a complicated example, and let's solve that together. Complex example, okay? A bit of complexity. Let's make it like this, okay? 5 is greater than equals to 3 and 2 is greater than equals to 4, or 4 is not, and 5 is equals to 5. I want you guys to tell me what should be the answer of this. Okay, try to use not use Python first up, and then we will talk about it. I see quick responses. I see trues already. Good stuff. I cannot know the answer already because I just randomly created this question, but let's see if you are thinking the same way I am thinking. Okay, let's go at it one by one. Okay, let's solve this case first. What should be the answer output of this case? 5 is greater than equals to 3, which is true, and 2 is less than equals to 4. 2 is less than equals to 4, which is also true. So this becomes true. True and true is true. Or now whatever we don't care what is here. So yep, I appreciate the quick answers. So this should be true. So I hope everyone's very clear with combined and individual comparative statements. Okay, these are called logical comparisons in Python, and all these are called logical operators. Okay, so we can name it to be logical comparisons in Python. Okay. Now let me use one example. Example is, this is the question. This is the problem statement. Ask the user for a porosity input, and based on porosity values, display the outputs accordingly. Okay. So basically, I want to type a input statement, and based on that, so input statement, for example, porosity is an input. Right now, I'll provide none. Okay. Just a placeholder. Then what I will do is I will apply this if else condition. And this is where we will understand if else conditions. You see, every if else condition, uh, it has the center of it is the logical comparisons that we just saw. Okay. So the logic here is, if whatever porosity values entered here, if that is greater than 20%, we print that, hey, porosity is greater than 20%. Otherwise, we print porosity is less than 20%, whatever. Okay. So are we able to understand what I mean by here? Okay. Okay. Let me do something. Okay. Let me ask the user input. Hey, enter porosity in percentage. Now, again, looking at the chat, I'm asking you, is this is this code block is this code block correct, or is there some problem based on the last session? Is there some problem with this? The hint is I'm using input state. I'm asking for a user input. Exactly. So Kapil has spotted it out. We need to remember that percentage is fine, but the input statement, the result of the input statement, which is stored in porosity. Yes, Abhishek, it is going to be a string. And can we compare a string with a with this with what do you call, with a number? No. Will the code run? Let's see. 25. The code will not even run, because this comparison statement, it assumes that the data types on both of the sides of the comparison are eligible for comparison. You cannot compare an apple with an orange. You need to compare a good apple with a bad apple. Okay. So that's the logic. But if I replace it with let's say float. Okay. Now if I run it 25, now tell me, if I input 25, what will be the output of this entire code block? Expecting some answers from you. If I press enter, what do you think will be the output? Will it be the first section or the second section? Will it result in, yes, if condition is true. So if I provide 25, what happens? Now let me explain, let me postmortem it and explain it what is happening here. So the step one is the porosity input is taken in. Then we get to this line. Okay. This line, porosity is greater. So first this is executed. Okay. Porosity greater than equals to 20. So what is the value of porosity? 25. It checks whether 25 is greater than equals to 20. The answer, if I provide this 25 is greater than equals to 20, this gives me true. So basically, if condition checks whether this, whatever follows the if condition, that statement, whether that statement is true. If that statement is true, the block within the if statement, always remember, as soon as you type the if statement, for example, if I see here, if true, and I provide a colon and I press enter, by default you will see that the line starts here. It's something similar in C++. If you have seen in C++, the if condition has this curly braces thing. Okay, you have these curly braces and all. Whatever you want to write for this if statement is within these curly braces. But in Python, you have this, which is called a tab, which is called an indent. Okay, print true. Okay, so you can see this is what happens. So basically, if this was false, the true is not printed. So this should be very clear. If condition. So if condition checks whether the next part of the statement, is it true? If yes, get inside, print whatever, do whatever is inside, otherwise get out of here. That's all. So basically 25 is greater than 20, which is true. this part is printed. If I repeat the same thing with 17% porosity, you can see porosity is less than. Basically, it means the other else statement is printed. Now you will ask me that, hey, is this all? Okay. Is this, can we only have two statements, if or else? What if I wanted to add something like a switch kind of thing, that hey, if this is true, then this. Otherwise, if this is true, then this. Otherwise, if this is true, then this. If not, if none of them are true, then finally this. Remember, else is always the worst case scenario when nothing is true. Okay, let's look at one more example, which has elif as well. Okay, which has elif statements as well. Let me find that example. Okay, I have already. I'll copy it here directly to save some time. So basically, what's happening here is I'm asking the same porosity input again. Now there are two conditions to be checked for, and then there is one else statement. Okay, first I will check whether this condition is true. If that is the case, then this will be printed. Then if this condition is not true, then elif is checked for. If elif condition is true, then this is printed. If none of the above two conditions are true, then the final one is printed. So the logic is, if porosity is greater than 25%, then this is a porous sandstone. Otherwise, if porosity is less than 25 and it is greater than 15, then it's still a sandstone, but it is a tight sandstone. But if both of the conditions are false, then I would say that maybe it's a carbonate. Okay. So let's check for various conditions, and I will ask you again so that I verify whether you have understood the if else. So suppose I provide 27. Okay. I need your answers in three words. The options are condition 1, condition 2, and last case scenario. So if I provide 27, which condition will be executed? Correct. If I rerun it, if I provide 25, which will be executed? Again, first, because the equality sign is in first. If I repeat this again and I provide, let's say 17, which condition will be executed? Condition 2. You can see this is a tight sandstone. And if I repeat this and I provide, let's say, if I provide, let's say, minus 100, what will be executed? I'm providing minus 100. So pay attention, what will be executed? It's very simple. Just focus on one condition at a time. If that is true, yes. So basically it checks, as I provide minus 100, then porosity becomes minus 100. Is minus 100 greater than 25? Of course not. Goes to the next condition. Is it less than 25? Yes. Is it greater than 15? No. So it becomes false. So this is not printed. Hence, else condition is printed. So basically, maybe it is a carbonate. So basically, we have to, now what would you suggest? There is some problem with this logic, right? So the good thing should be to provide one more elif statement. Elif poro greater than equals to, let's say we provide a threshold of valid porosity values to be 3%, and poro is less than 15 percentage. Then we provide this, control C, control V. Otherwise, the worst case scenario should always be those ones which may be also good enough in capturing some errors. Invalid porosity value. Okay. So if I run it again and I provide the minus 100, you can see invalid porosity value. So are we very clear with the if else conditions? Okay. I'll paste this entire, if you want to, run the same thing in your code notebook, I'm pasting this in the chat. But are we good enough with the if else conditions? Okay, very easy, very understandable. Let's now move on to the next part of today's session 2, the functions, which is going to be really fun. Okay, let's now look at functions. Functions. All right. So let's assume a scenario. For example, you have a quadratic equation. Okay, and you want to create a you want to take the user in solve 3 steps after that x is obtained and return the final value. Okay, basically you want to take x as an input, x as an input. Okay, this is a comment. Okay, you want to take x as an input, run step 1 plus step 2 plus step 3, 3 steps one after the other using x, and finally return the output of the run as y. This is something that I want to do. Ideally, the way to do that is, for example, x equals to, let's say, 3. Okay. Step 1 is to apply some quadratic equation, let's say x to the power 2. Step 2, step 2 is step 1. I want to add some, let's say, 5 to that. And step 3 is step 2 multiplied by x. Okay. And I want to return the value of step 3. Basically, this is like wasting a lot of lines of code for nothing. And this is not even clear. Basically, what we are doing here is x squared plus, let's say, 5x, let's say, okay. 5x plus 5, step 2 plus 5, okay. So that it looks like a quadratic equation. Okay. So x squared plus 5x plus 5. Okay. This is something that you want to do. Now, will you keep on writing this quadratic equation everywhere you go down the code? For example, if you are 1,000 lines down the code, now you don't even remember what were the coefficients of the quadratic equation. So the code reusability is in question here, and we still have to, every time, even if you remember, you would have to type the entire long statement again. What if there was a way to create a function of that that takes in as an input, it takes in x as an input, does some computation, returns the output as the y, and you can use it wherever you, and it has a name that you provide it, and you can use it wherever you want. So that's where functions come in. So let's create a function. The way to create a function is def keyword and then function name, then inputs, and then okay, output equals to input plus 1, let's say, inputs plus 1, and then a return statement. Okay, so you can see function and you can use it like this. Function name, you provide an input. So this input 10, it goes and it is assigned to this inputs variable, which goes inside the function. That is added, 1 is added to that input statement, and output is printed out. Okay, so basically if I run it, you can see 10 goes into the function, 1 is added, 1 is assigned to output, 10 plus 1 is assigned to the output, and the final output is returned, which is this one. So this is the entire theory of a function. What if I wanted to do the same thing for this quadratic equation? Def quadratic. Now this blue name is your creation. You can provide whatever name you want. Okay. Quadratic calculator. Okay, you ask for an x input, and that y value is basically nothing but this quadratic equation, and you can return the value of y. So basically whatever happens in here is private. No one can see it except you. Because when you are using a function, for example, now you are using this function, all you have to do is provide the x value, x equals to 2, and it runs. Okay, so I will give you everyone, I want you guys, whoever has the programming console open on their end, I want to give you guys a problem statement. Okay, example problem: create a function squarer that takes x as an input and returns x, the square of x. I want you guys to take a shot at it and paste your functions inside the chat. I want you guys to try this one and paste whatever function you have created in the chat, so that I can understand, I can see that you have understood at least the syntax of how to create a function. I've given the example here, and let's take 1 to 2 minutes for whoever wants to solve it. And I'm expecting answers in the chat. Perfect. Looks like everyone's able to understand how to create it. So the way to create it is def keyword will always be there. It is Python's identification that it's a function. I see correct answers in the chat. Good stuff. So squarer, x as an input, x squared equals to x to the power 2, return x squared. And to use it, so this is called a function definition, guys. Okay, this is called a function definition. This is like a template that the function is following, and this is called a function execution. Okay, this is called a function execution or function call. So I can use it now. Squarer, when I provided 3, the output should be 9. Now remember, it's again like this function is popping a value out based on the computations. Whatever you are returning, it is popped out, it is thrown out. It's like a fruit. A function is a tree, it is throwing a fruit out. So you can create a polybag as a variable, x squared, and now x squared will have stored the value. X squared will have stored the value, right? So this is about a function. Now the problem here is, if I use the squarer function and I don't provide any input, it will give me an error because a function is expecting an input. There are two ways to solve this problem. Let's look at the first bad way, okay? Which is called default arguments. What you can do is, while defining a function, squarer, let's call it squarer new. We can provide a default value to the function x default, so that whenever I run this function again, If I forget, somehow, if I forget to provide X, the program still runs. This red kind of bad looking error, it does not show up. So now I want you guys to tell me, if I run the same thing again without any input, what will be the output? If I run it just like this, I'm not providing any X. If I run the squarer new without any input, exactly, it will not give an error this time. So you see just how much of a difference providing a default statement, default value makes to the function. Okay, so now this comes in handy. Let's look at multi input functions. Okay, we can ask for multiple inputs to the function, right? For example, def Gaussian. So I think all of us know that the Gaussian function is e to the power something like e to the power minus x squared plus y squared, something like that. Okay, so in that case we want two inputs, x equals to, let's say, if I provide x without default argument and y with a default argument of 0, I can calculate z equals to, I know that the value of e is 2.71 something. Okay, to the power minus x squared minus y squared. Okay, if I am incorrect about the Gaussian formula, pardon me, but just assume this is some calculation that has two inputs and some calculation that you don't want to tell the world. That's why you're creating a function. Return z. Now tell me, if I run Gaussian without an input, will it run or will it give me an error? Simple question. If I run it without any input, will it run or will it give me an error? It will give us an error because yes, we have y with the default argument, default value. One input is still not defined. Okay, so you need to understand that at bare minimum, one input has to be defined. So if I provide 5 as an input, what is 5 now? What is 5? 5 is x. So you can see the final output is returned. Okay. However, you can also override the default arguments. Y equals to comma y equals to 3. This is why they are called positional arguments, because x goes to the variable defined in its position, y goes to the variable defined in its position. So 5 goes to this variable, 3 goes to this variable. Okay, so if I run it, now it runs. Now again, one more example. Okay, one more example. Def random func. Okay, x equals to 2, y equals to 3, z equals to 4, l equals to hey, m equals to pro. Okay, and inside the function we do nothing but we just print. We don't, there is no mandate to return something. We can just print ha ha ha. Okay, just a bit of laugh. Now tell me something. If I run this now, I'll reframe my question. What is the minimum number of arguments or the inputs that we need to provide here when we are executing the function? How many minimum number of arguments does the random func need? Brilliant, Krunal. We don't need to provide anything because absolutely every single argument has a default value with it. So if I run it, you can see the ha 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 happens even without any input statement. But if I remove two of them like this, x comma y, now tell me how many minimum number of inputs we require for our random func. Okay, exactly. And when I run it this time, you can see this is exactly what the error also talks to us about. That hey, you need two required positional arguments x and y, because x and y are having, neither they are having values, neither they nor they, do they have any default values. All right. So let me call this as random function new uh, old. Okay, so that when you run it you remember why this happened, and this becomes random function new, the same copy of this. Okay, random function new, and it has equals to 0 and equals to 0. All right, we are good enough in the functions, I think. Okay, right. So let's see some applications of a function. Okay, let's see along with me. So let me use them and explain you how we can use functions. Okay, so which example should I use? A good old Darcy calculator. The same thing that we did in so many lines of code. Now once we define a function, right, once we define a function, what I can do is I can use the Darcy calculator in one line of code. Okay, 1 2 3 4 5, okay, whatever. Just don't just forget about the logicality of things. As a reservoir engineer, just ignore them right now, but as a Python programmer, this is just one line of code, and it is very understandable because we can see Darcy calculator name is much more understandable for some newbie as compared to write showing them the whole code. Okay, so using functions also makes things much more readable or presentable, so your code becomes better on readability aspect as well. Okay, so that's about the Darcy calculator. What do we have? Let's look at uh exponential decline function. Exponential decline function. So you can create an exponential decline function like this, where you are asking for initial flow rate, the b decline rate, and the time. And you need to, there is one mathematical library in Python, you can import that, import math. If you do not want to use 2.71 and rather you want to use the actual value of 2.71 or e, you can use math.exp and provide in that you can provide minus b to and t. Okay, and you run it, and you can see q exponential 1000, 0.05, and at t equals to 0 the answer should be 1000 only, right? So you can see q exponential. Okay, let's look at a few more examples if I have. Okay, let me look at one good example. Fractional flow, everyone knows about fractional flow. What is fractional flow? When we are trying to produce from a reservoir, we tend to inject water at times so that the water floods oil to the oil well, a typical fundamental of water flooding. For water flooding to work out well, we want our water viscosity and oil viscosity to be shoulder on shoulder, so that the mobility of both of them is at par with each other. Ideally you want a piston kind of flow, finger through oil globules. If your water is very thin and your oil is very thick, your water will just rush through the oil, and it will not be flooding or pushing the oil. And this calculation of fractional flow, it tells you how much in the current scenario, based on your water viscosity and oil viscosity, how much is your water cut on the particular position or your production well. So these are the three calculations, like I told you, step 1, step 2, step 3 kind of things. Now this is an algorithm, and you do not want to keep on writing this entire thing every time a water flooding scenario is encountered in your code. What you can do rather is you can create a function like this. I'm saving some time because this is just a demonstration. in your own projects you will see some other functions that you will create. You will rarely create example functions again. So I want you guys to remember the fundamental concepts of creating a function. So you can see all the things that you see up here, they are happening in this function, fractional flow calculator. The aim is to return the fw. Okay, so basically the input is sw, 1 minus sw, which is so, assuming that our reservoir has oil and water only. So if 20% water saturation is there, 80% oil saturation will be there, and vice versa. Viscosity of water is important, oil viscosity is important, and all of them combined, they together help us calculate fractional flow of water. And you can see that's exactly what's happening, and we are returning this entire thing. So you can use the fractional flow calculator and provide all of them. Now again, we have default values. So even if you did not provide all of them, at default, you can have them. One hint for everyone, one good practice is whatever function you have, you can press shift plus tab to see the default values. If you press shift plus tab, you can see the default values. Okay. Now, what if you ask me that, hey, can I provide some documentation? Yes, you can. You can use this symbol. Okay. 3 string marks. Whatever you provide within this, for example, if I provide this, if I provide this as a documentation, this will not be executed in Python. Okay. It will not be executed in Python. Just that if I press shift plus tab from within the function, you can see the entire doc string. This is called a doc string, which is the documentation of a function. You can see the theory is displayed here. Okay. So I can write my message. Hey, this is fractional flow documentation. So you can see if I press shift plus tab, fractional flow documentation. Okay, so these were a few examples about functions. Everyone clear about how to use a function? Some of your own calculations that you can set up using a function. If you are at least feeling 5 out of 10, 5 on 10 kind of confidence, that's good enough. Trust me, it is. Because the syntax, no one expects you to remember. Just that you must have a reference document with you, which will be this notebook, and some logics that you must have understood in the past. And you do understand how to create a function. Okay. And yep, let's look at the third topic for today. Or maybe let's solve some example. Okay, let's solve some example. So basically, this that you see on your screen, question 1, asking the user for porosity input and printing the according statement. I want you guys to create a function of it. The idea is to create a function whose input is porosity, and the print statement, I mean, this part goes in as the function input. If you want to return this string as output, you can return it. If you want to print it, you can print it. Both are two different things. A return can be stored in a variable. A print is just a demonstration. It's just a pop-up print. It can never be stored somewhere. Okay. So I want you guys to, just transform this logic to a function. I want to see how you name a function, how you're transforming logic to code. How can you do that? One of the very important considerations, logic to code. Okay, let's take 2 minutes. If you want me to paste it in the chat, I will paste it. I want you guys to transform this to a function format. The idea is you pass on porosity value as an input, and the resultant logic is returned as an output based on the truth value. Is anyone able to do that? Let me do that on your behalf. All right, Kapil has an answer for us. The naming is good. Porosity check tells the user what is happening in the function. Porosity is taken in as an input. Then we are, let's see what, let me copy Kapil's answer in my code, converting question one, porosity check to a function. So there you go. This is the logic that we had. We had a porosity. Now, because we are taking this as a user input already when we are using a function, we do not need this input statement because we are already providing it as a part of the function. If you use this as well and then inside the function again you are initializing the porosity value, then there was no need. This is again anyway going to overwrite what you expected or imported, right? So we can remove this. So this porosity comes in checked for f poros. Yep, Krunal, I think this is also good. Return, you need to return. I mean, yeah, you are not returning anything, which is good, which is okay, but you don't need to unnecessarily type the return keyword if you are not returning anyone, right? So in this case, this is one variant of creating this function. Okay, now let's try it. Porosity check. If I provide 10, you can see maybe it is a carbonate. Now what if I wanted to return this? Because if I store this as result like this, okay, and I check the result, nothing is printed. Result is having no value. Okay, type of result none type, because we are printing things. Printing is as if the fruit on the tree is just smelling good. It has not come to the ground to be captured in your polybag. Okay, so in order to return something, we can, what we can do is return statement. We can create a return statement as a, rather than printing it, let me create another function, and this should finally seal the deal about functions. Okay, rather than printing it, I will return things. Return this statement. Okay, this is a sandstone. Otherwise, return this. This is a type sandstone. Okay, you can use whatever logic you want. Okay, output, you can create an output variable and store this string inside the output and return this output. Both of them are the same thing. Okay, you can repeat this. Output equals to, this is a tight sandstone. Return output. Okay, and again repeat this for other cases as well. Maybe it's a carbonate. This should be very clear now what a function is doing. Return output. Else we don't want to return an error, so let the error be an error. Okay, so porosity check. Now if I run it, let's check with the error first. -10. Okay, it will not return any value. So if we store this as v, you will see that v is none. Okay, but if we provide 10, you can see v has a statement inside it. So is this very clear? If it is clear, type yes in the chat so that we can move on to the final topic for this session, which is the very important iterative power of computers, for loops. I want 3 to 4 yeses or thumbs up so that we move forward. That's like my motivation. All right. Final topic for today is loops and iterations. Oops. Okay. We will look at one of the very popular loops, which is a for loop. Okay. Because I rarely use while loops. So let's focus on the for loop. For example, let's assume a use case. For example, you have a list of numbers. You want to pick one number at a time and you want to print the square of that number. How can you do that in Python? So first create a list of numbers. The question one, please focus. Okay. Question number one, 3.1. Let's call it 3.1. Create a list of numbers and print square of them, square of each. Okay. Let me give you a shortcut on how to create a long list of numbers. Okay. My numbers. There is something called a range function in Python. You can start at a particular number, end at a particular number. That ending portion is not included. Okay. One number before it is included. So basically it will be a list from 0 to 100. It is a a pseudo list. So in order to convert it to a list, you have to provide the list command here. Okay, so you can see if I print the my numbers, it is from 0 to 100. Now for number in my numbers, let's first print one by one the number. Okay, number. So you can see it is picking up one number at a time. So for number in my numbers, so it will pick one element at a time. So number becomes at the first step of the iteration, number becomes 0, 0 is printed. Then it goes again, 1 is picked up, 1 is printed. So basically it picks up. So this statement number in numbers, for number in numbers, it's as if you are picking up one by one every number, then running the code cell within the for loop. Okay. So right now we are printing the number as it is. So we don't have to worry about it. Also note that no one likes this tall giraffe. We can provide a separator here to be space. What happened? /t. Nope, still not working. Why is it not working? Just let me check. Oh, end, sorry. End should be space. So you can see 0 is picked up, 1 is picked up, every number is printed because the current execution of the for loop involves just printing the number. But what if now I square it? So you can see 0 is picked up, the square of 0 is printed, 1 is picked up, square of 1 is printed, 4 is picked up, 2 is picked up, square of 2 is printed, and so on. What if I wanted to add 10 to the square of the number and then print it? You can see accordingly the calculations are modified. What if I wanted to subtract 10 from this 10? You can see again the same thing. What if I wanted to add the number cube to this? So you can do whatever you want within the for loop, but just that it will be repeated on every number in that list. So this part is always a list or a tuple or an iterator. It should have a ordered arrangement of elements. For example, for letter in Divyanshu, because this is also an ordered arrangement of something, right? Print letter and should be underscore. So you can see every letter is picked up one by one and printed one after the other. If you ignore this end, you can see every letter is picked up one by one and it is just printed. Okay, so this is a slight introduction about easy little introduction about what is the logic of a for loop. Now let's solve some problems. Okay, so we have this my numbers list, right? And we have also seen how to square it. What if we wanted to create a my squared numbers list, which is initially an empty list. Okay, what we will do is we will take the my numbers list, take one by one element from that, square it, and keep on adding that number to this list, right? So we know how to do that, right? So for number in, let's use n. Okay, for n in my numbers, n squared is equals to n to the power 2. Okay, my squared numbers equals to my squared numbers plus, because we know that two lists can be added together. So now if I look at my squared numbers, it is a list with the square of all the numbers which were stored in my numbers. A very simple application of a for loop. Okay, good. Now everyone knows something about the Newton-Raphson's method, a sweet application of a for loop to solve some actual problems. Okay, and if you understand this, this can help you solve a lot of problems in whatever numerical textbooks you are reading. I am from the reservoir engineering background, so I can see that I solved a few examples in reservoir engineering books like Tariq Ahmed and LP Dake. I mean, if you are reading some other book or whatever domain you belong to, there'll always be cases which will be solved using numerical methods, because the root finding of complex equations, which are called transcendental equations, they are not possible using analytical methods. Rather, you need to use numerical methods to solve them. And Newton-Raphson's method is just one method which helps you do that. It helps you solve a particular equation, and it always converges in terms of the solution. So the solution will almost always be there. You can almost always find out the solution. Okay. So let's look at a few Newton-Raphson's example solutions. Okay. And then we will conclude our session. Okay. So the basic formula for Newton-Raphson is x new equals to x old minus fx divided by f dash x. Okay, so this is the, and you keep on repeating this. So basically you have an fx equals to 0 kind of thing, you have an fx equals to 0 kind of thing, you have fx equals to 0 kind of thing. This is on the left hand side, you have the entire expression that you want to solve for. You take the initial root x, initial guess, whatever alpha, whatever value you want to take, and you keep on updating that using the Newton-Raphson's concept, which is this one. Where this comes from the Taylor series expansion of any function up to the first order. Okay, so we can solve a few things, but the idea here is the repeat part that you see here, the repeat that you see here, this repeat is basically what for loop will help us to do. Repetitive task is what for loop helps us to do. Okay, first let's see how to find a square root of a number using a Newton-Raphson's method. Square root of a number. Okay, basically the equation here is x squared equals to n. Okay, so basically we want to find x here. Okay, so what is fx? fx is, let's create a function, def fx takes in x, returns what? Takes two things, f, x, and n. Basically what will be the f dash x? So in this case fx is equals to, take everything to the left hand side, x to the power 2 minus n equals to 0. So basically x to the power 2 minus n becomes your fx. Okay. And what is f dash x? F dash x, it is what? 2x. As simple as that. 2x. Okay. So fx will be what? X to the power 2 minus n. And what is f dash x? It is 2 multiplied by x. Okay. Now, how many times, what will be the initial guess? Let's start with initial guess. Okay. X initial guess equals to, and let's also take n. N is the number we want to find the square root of. Let's say n is 100. X initial, let's take it to be 0, or let's say 2. Okay. What is Newton-Raphson's method? Newton-Raphson's method is x new is equals to x old minus fx divided by f dash x. So basically, let's not use the name x initial. Yeah, let's use only x underscore, and we will repeat it for repeat in how many times you want to repeat? The range of, let's say, 1,000 times you want to repeat. What thing you want to repeat? You want to update the value of x underscore. X underscore equals to x underscore minus fx upon fx. What is fx? You pass on x underscore and you pass on n divided by f dash x. What is f dash x requiring? It only requires us to provide x underscore. You repeat this for 1,000 iterations. You can see your initial guess. You did not know the square root of 100. You assume that it was 2. But after you solve it for 100 iterations or 1,000 iterations, you can see the underscore x underscore's final value is 10.0. Okay. For example, let's use 2, 6. Let's use a number. Okay. Let's use a very complex number. 2, 5, 6, 8, 9, 6, 3, 2, 1, 1, 2. Okay. 15.52. And we take the same initial guess. And this is a proof that Newton-Raphson's method almost always converges. Okay. So now if we repeat it, let's verify now. This is the Newton-Raphson prediction of square root of x, square root of n. Okay. This is the Newton-Raphson prediction. Let's try by n to the power 0.5. You can see how close both of them are, almost exactly equal. There might be some differences in later significant digits, but they are almost exactly equal. If you reduce the number of iterations, let's see how close we get in 10 iterations. You can see in 10 iterations, you are not close. Okay. But if you increase it to, let's say, 20 iterations, you can see now again. So it requires somewhere around 10 to 20 iterations to get from 2 to 15, 2 to the actual root. Okay. So basically, this was all about this thing. I will share a link with you guys in the chat so that you take this solving the Newton-Raphson's algorithm, that example, and you see how reservoir engineers can use Newton-Raphson's method to find liquid permeability in core analysis. Okay. So I'll be sharing this in the chat. We open the chat. This is from my GitHub repository. The reference textbook for this is Tariq Ahmed, which is a reservoir engineering book. A very important problem is that if you bring in core samples from the actual rock and you test for permeability in laboratories, there will be a difference. If you are using air for permeability checking, air has a benefit that air can, jump from the solid particles. Air does not stick to the solid particles because air is normally non-wetting. So the permeability that you find using air as the fluid will always be higher. But there was a scientist called Klinkenberg, and what they did was they provided a complex looking equation that can be used iteratively to start with air permeability as the initial guess, and you can iteratively use that equation, and the final solution will converge to the liquid permeability. Okay, so this entire concept that we just learned in Python, back when that Klinkenberg effect was created, they did not have computational resources, so they used to do that by hand. Now you can use the same logic. All you have to do is replace the fx and f dash x accordingly, and the same logic for the number of iterations can be used to find out liquid permeability using air permeability. And you will see that the Newton-Raphson method actually gets you very close to the actual, observed liquid permeability. Okay, so just imagine pure mathematics and computational resource helping you find out the reality of something, of some physics. Okay, you had no clue about what was the actual liquid permeability. All you did was you used Newton-Raphson's method to iterate from the initial guess to reach to the ultimate liquid permeability. So this is, I mean, before we meet tomorrow, I would like you guys to have a look at it. I've shared it in the chat. Now I think we can have a few minutes for questions and answers. What is math.exp? Yeah, thanks for reminding me that. So one thing that I want you guys to know is, so let me find that squarer function. Where was that? Squarer. So there's something called a module in Python, okay? So if I go to this folder, I can create a Python script, okay? My funcs.py, and you don't have to do this. This is just to explain some concept, okay? So I have copied that function that I created in this script, and I can create one more function similar to this, cuber, okay? Cuber, and I can return x to the power 3, x cubed, x cubed. Okay, now this is called a module because it is a collection of functions within a script. .py is a symbol for a script, Python script. Okay, now it is just a repository of various functions that you have created. Now I can use this. This is the benefit of creating functions, because now what I can do is I can import my funcs. What was the name? My funcs. Okay, and I can use whatever functions were there in my funcs dot squarer new 3, it returns 9. Now math is one similar thing, similar to a my funcs, and it has a similar function like the squarer new, which is exp and a lot of other mathematical functions. Okay, so basically this is what I did when I did math.exp. What I did there was I imported math first, imported math, import math, and then math.exp to the power 3. It's similar to, it's similar to 2.71 to the power 3. Sorry, to the power 3. Okay, this is highly approximated, but this gives you the actual value. So do you understand what this is? It's just here we access the squarer function from a particular module. Similarly, here we access the exponential function from this particular module. Am I clear? Hope I am. Any other questions? The plot from session 1. Okay. Plot, we will have a separate session on plottings, so that's not an issue. But yeah, here it is. Dot plot. Porosity is reducing with depth. Right now, this is not even a correct plot because the depth axis has to be changed. So this is just a slide demo. Anyone, any other doubts? Feel free to ask before we wrap for today. These three things are very important: the for loops, the functions, and the if else's, because this is where programming actually starts. You will keep on applying logics and converting them to these kind of programs every now and then. You will create functions a lot. I mean, in data science, you import data, you can create a function that has a few data processing steps. For example, if you have a data set which has some problems every time, it's coming out of a software. uh, for example, it is coming out of some production profiling software which has yeah, I will upload the codes after this session to the teams folder itself. You can access it from there. Okay, and also I've shared the link to my GitHub repository in the chat. I have a huge set of codes and everything, all my learning journey up there on the GitHub repository. There are Python courses there, there are machine learning courses, data science courses. So if you have the appetite to learn more on your free time, feel free to hop over there, connect with me on LinkedIn for more resources, whatever you want to do. So yeah, we can create our functions, and every step of the data science workflow can be a different functions, so that further in the future you can repeat, reuse that same function for some other project as well. And that's the benefit. Similarly, for example, the squaring and cubing, this is a fundamental math kind of thing. This is just an example. I can use the math squarer and cuber across my projects. Similarly, as a reservoir engineer, I know fractional flow theory is useful across the projects. I can use them for simulations or whatever. So why not create a separate module and have all the functions stored there? And that's why functions are like very, they're priceless. So please focus on these functions today after the session, and we will be starting with data analysis tools tomorrow, and practice a few projects by the evening tomorrow. All right, I think we are good to wrap things up for today. Anyone, if you have any doubts, otherwise, if not, I think we're good to go. Looks like there are no doubts. I think, okay. Thanks, everyone. Happy Saturday. Happy Sunday. See you tomorrow.
Thank you, Divyanshu, and thank you all for joining. Let's meet tomorrow at 1:30 p.m. Thank you.